In this video, we're going to learn about circumscribed angles. A circumscribed angle on a circle is an angle that is composed of two tangent lines to the circle. So for example, here we've got a circumscribed angle right here, and each side of the angle is formed by a tangent line to the circle. This top tangent line intersects the circle at exactly one point right there, and this bottom tangent line intersects the circle at exactly one point right there. So let's go ahead and label this as a circumscribed angle. Now you notice that the circumscribed angle divides the circle into two arcs. Closest to the circumscribed angle, there is a minor arc, a smaller arc. So let's label that as minor arc. And on the opposite side, there's another arc, a major arc. And the measure of the circumscribed angle is related to the measures of the major and minor arcs in the following way. We have that the circumscribed angle, the measure of that angle is equal to half the difference of the two arcs. So we take the major arc and subtract the minor arc to get the difference of the arcs, and then the circumscribed angle is just that difference divided by 2. Now we want to use this fact to solve for each of the missing variables in the diagrams below. So first of all, in this diagram we want to solve for x. X is a circumscribed angle, so we can go ahead and plug it into this formula here. X equals the difference of the two arcs divided by 2. Alright, we also have that the minor arc is 100 degrees. So we'll have minus 100. But what is the major arc? It doesn't tell us in the diagram, so we're going to have to figure this out. Well, let's think. There's 360 degrees in the circle, so we can get the measure of the major arc by just subtracting off this minor arc of 100 degrees. So the major arc is just 360 degrees minus that 100 degrees that's spent on the minor arc, which gives us 260 degrees. So 260 degrees is the measure of the major arc. And then to solve for x, we just go ahead and compute. So x is equal to 260 minus 100, that's 160, and then that's divided by 2, so x is equal to 80. And there we go, there is x. Okay, so how about in the next problem? We want to solve for the missing variable y, and we know the measure of the circumscribed angle this time. It's 40 degrees. So let's go ahead and set up our formula again. So 40 degrees, that's the circumscribed angle. That's equal to the difference in arcs, then divided by 2. This time we're given the major arc, that's y, that's what we're solving for. But we're not given the minor arc, and that's what we need to subtract from the major arc. So how can we figure out this minor arc here? Well, let's just use the same reasoning as before. Again, there's 360 degrees total in a circle, so the minor arc is just 360 degrees minus the y that's spent on the major arc. So the minor arc is 360 minus y degrees. So we'll plug that into our formula, 360 minus y, and then just go ahead and solve for y in this equation. So simplifying, we have that 40 is equal to, let's go ahead and distribute this negative on the numerator. So y minus 360, then plus y, and that's over 2. So 40 is equal to, we've got a y then plus y, so that's 2y, and then minus 360, and all that's over 2. Let's bring this up here to keep on simplifying. So 40 is equal to, well, 2y over 2, that's just y, and then 360 over 2, that's just 180, so y minus 180. And then we can add 180 to both sides and get 220 is equal to y. So there we go, we found y. Y is just 220. Next up, let's solve for x and y in the diagram below. Alright, so how do we solve for x and y here? Why don't we start by just trying to create some equations that involve x and y. First of all, there's the formula that is the entire focus of this lesson. The measure of the circumscribed angle is equal to half the difference of the arcs. Our circumscribed angle is 40, so let's write that down. 40 is equal to half the difference of the arcs. Our major arc is on the opposite side as the circumscribed angle, so it's this 2y degrees over here. That is our major arc, so that goes first. 2y, and then minus our minor arc. And our minor arc is on the other side, the same side as the circumscribed angle. It's this x minus 6. Okay, so that's cool. We've got an equation involving x and y, but there is one little issue, and that's how can we solve for x and y with just one equation involving both of them? In order to solve for x and y, we need two equations. A system of two variables requires two equations in order to solve it. So how can we get another equation? Well, remember again that the major arc and the minor arc have to add up to 360 degrees. So that can be our next equation. 2y, that's the major arc, plus x minus 6, that's the minor arc, that has to equal 360 degrees. And now it's just a matter of solving the system. Before we get started on that, let's just go ahead and simplify each equation as much as possible. So in this equation here, let's go ahead and multiply both sides by 2 to cancel out this fraction here. So we'll have 40 times 2, which is 80, is equal to the numerator 2y minus x minus 6. And then we can go ahead and distribute that negative sign over the parentheses. So 80 is equal to 2y minus x plus 6. How about we get the variables all on one side? So get rid of this plus 6, subtract 6 from both sides, get 74 equals 2y minus x. Okay, now let's do a similar thing for the other equation. So we have right now that 2y plus x minus 6 equals 360. All we really need to do is add 6 to both sides to cancel out this minus 6. So we'll get 2y plus x equals 360 plus 6, which is 366. And hey, look, there's a 2y plus x and a 2y minus x. So if we add these equations together, we can cancel out the plus x and the minus x. Let's move this equation to be underneath this one, and we'll write it with the variables on the left-hand side this time. So 2y minus x is equal to 74. And we can go ahead and add these equations. We'll get 2y plus 2y is 4y, x minus x cancels, and 366 plus 74 is 440. Now to solve for y, just divide both sides by 4. That cancels. We get y is equal to 440 divided by 4, which is 110. So there we go. We've got y. Y is 110. And solving for x is easy now that we know what y is. We can just back substitute. And maybe we'll take this equation here to back substitute because that has an x already there. So all we'll have to do is sub in the 2y, subtract off to get x alone. We'll bring that over here. So 2y becomes 2 times 110. And then plus x is equal to 366. So 220 plus x equals 366. Subtract 220 from both sides and get x is equal to 146. So there we go. We've got x as well. Alright, so we've been using this formula that the circumscribed angle is equal to half of the difference of the arcs, but why does it actually work in the first place? Well, here we're going to prove it. So we want to prove the formula that the circumscribed angle equals half of the quantity major arc minus minor arc. And we've got a little diagram here to help us out. Why don't we call the circumscribed angle x, just to ease notation a little bit. So the circumscribed angle is x, and our goal will be to express the major arc and the minor arc in terms of x. But how do we do that? Well, first of all, notice that the minor arc here is equal to the measure of this central angle right over here. Why don't we call that C for central angle? And now remember that a circumscribed angle is composed of two tangent segments to the circle, and tangent segments are perpendicular to the radius of the circle. So this is a right angle over here, and that is a right angle there also. So hey, we've got a quadrilateral here. There's 4 sides, and we know that the sum of all the angles of a quadrilateral has to be 360 degrees. So if we write that down in terms of the angles here, C, X, and our two 90-degree angles, we'll have an equation that we can solve for C in terms of X. So adding up all the angles, we have our C plus X plus our two right angles, 90 degrees each. That has to equal 360. Simplifying, we have that C plus X plus 180 is equal to 360. And then we'll subtract 180 from both sides to get C plus X equals 360 minus 180, which is, well, also 180. So then C is equal to 180 minus X. And remember, C, that's the central angle, but that's also the measure of the minor arc. So we have that the minor arc is equal to 180 minus X, where X is the circumscribed angle. Alright, so how can we find the major arc now? Well, remember that the major arc and the minor arc together form the circle, which is comprised of 360 degrees. So the major arc is just equal to 360 degrees minus the minor arc. And we can substitute in this expression for the minor arc. So let's go ahead and do that. Major arc equals 360 minus the quantity 180 minus X. Let's go ahead and simplify. So major arc is equal to 360 minus 180 plus X. So then major arc is equal to 360 minus 180 is just 180, and then we have our plus X. Alright, so let's go ahead and substitute these into our formula to prove it. So we have that 1/2 of the major arc minus the minor arc is equal to 1/2 times the major arc is 180 plus X. So we'll go ahead and take that, substitute it into there, 180 plus X. And then the minor arc is 180 minus X, so take that, substitute it into there. So minus 180 minus X. And let's go ahead and simplify. So this is equal to 1/2 of 180 plus X, then minus 180, then plus X. Now we see this 180 cancels with this minus 180, and we just have 2x here. So this is equal to 1/2 of 2x. And 1/2 of 2x, well, that's just x. And x is the circumscribed angle. So there we go, we've got it. 1/2 the difference of the two arcs is equal to the circumscribed angle. That's what we wanted to prove. So now we know how to work with circumscribed angles in the context of circles. And in the future, we'll also learn how to work with inscribed and circumscribed shapes in general.